AI is writing our code, running our queries, and even making API calls on our behalf. But here's an uncomfortable truth. AI can't secure AI. So probabilistic models can hallucinate, they can misinterpret and guess, but authorization needs to be deterministic. So today I will show you how to build a real authorization model with AI assisting you, but not deciding for you. And I'll use not one, but two MCP servers for this. This is the Auth-Z MCP server and the SpiceDB Dev MCP server. And we're going to go from zero to a permission system in just a matter of minutes. So let's get started. What is MCP, you ask? Well, MCP, or Model Context Protocol, is how a tool can expose a capability to a large language model or an LLM. Think of it as a USB-C for AI. It's literally giving a model a set of well-defined, controlled operations. And in our case, the Auth-Z MCP server. This is a remote server that AI can query to search official docs, API references, and example schemas. And two, a SpiceDB Dev MCP server. Now this is a local in-memory SpiceDB instance that an AI can interact with to write schemas, relationships, test permissions, but all using structured tools. But together they give the model context and capabilities, not just text. And more importantly, we as developers of this permission system stay in control. And the distinction here is critical. LLMs are inherently probabilistic, but security cannot be. But with MCP, the AI isn't improvising your authorization logic, it's using deterministic operations that you can actually validate. So every schema write, every permission check, every relationship update is explicit and inspectable. Think of it this way, the AI drafts, you approve, and SpiceDB enforces. Let's take this for a spin and see it in action, and we'll start with a simple Google Docs style example. Hey, and don't forget to subscribe to this channel for more content on authorization. Also hit the like button. Back to the video. I've got the SpiceDB Dev MCP server running locally, which is in memory, so it's great for rapid iteration and learning. I'll start by building a sample schema that mimics a Google Docs style use case. So let me ask the AI, create a schema for a document sharing system. Documents have owners, editors, and viewers. Owners can share, editors can edit, viewers can read. And you'll see this MCP server use the write schema tool from the dev server to install the schema. Now this schema again is deterministic. The model hasn't hallucinated the structure, but it's used SpiceDB's exact syntax and validated that against the dev server. Now let's add some test data, again using text. I'm going to say, make Alice the owner of doc readme, Bob editor, and Charlie a viewer. This model uses update relationships, and you can also inspect this by just using relationships all. And now let's test for permissions. I'm just going to ask, can Charlie edit doc readme? Nope. Can Bob edit doc readme? Answer is yes. And this is real authorization logic that is running in memory. Now imagine this not just for humans, but also for AI agents and tools, where AI agents are calling APIs, they're writing files, and they're triggering workflows. Your authorization layer must treat these agents as first-class subjects, the same way we just treated Alice, Bob, and Charlie. And the thing is, it has to be able to operate at AI speed, which means being able to iterate through a schema, have an instant update, but also at the same time do consistent deterministic evaluation. And this is why authorization systems such as SpiceDB matter, and why MCP is such a big deal. AI tools can be granted the same controlled, introspectable access that humans get with no implicit trust. Let's use the Auth-Z MCP server to pivot to learning mode. I'm going to ask the AI, what is a caveat in SpiceDB? And because this Auth-Z MCP server gives the assistant searchable access to official documentation, it's pulling the definition straight from there. There you go. And here's a fun fact. Netflix actually contributed the caveats feature to SpiceDB, which, as you may know, is both free and open source. Finally, we can actually export the schema and the validation file. I'm just going to say, save schema to schema.z, and say validation to the tests folder, and you're done. We went from nothing to a clean, tested authorization model in just a matter of minutes, with the AI helping us along the way, but not deciding for us. And you can also pair this with the Auth Cloud to get a production-grade permission system running in just a few clicks. Here are my 3 key takeaways from this. 1, most importantly, AI cannot be used to secure AI, but AI can actually accelerate how you build security. 2, authorization must also be able to move at AI speed, and systems like SpiceDB let you treat agents, tools, and users the same way, deterministically. And lastly, MCP lets AI assist you without compromising full control. If you're building systems where AI interacts with your infrastructure, and honestly that's almost all of us now, this is a workflow worth exploring. The links to both MCP servers and SpiceDB is below. Do check it out, and I will see you in the next one.